Hello everyone, we are the Eco-Astronomical Engineers, and let's start the session. So for our project overview, this is our team structure. At the start we had 2 team managers, but with the technical advice from Satellites, they advised us to have one overall project manager and then a systems engineer, which took the information from everyone and funneled it to the project manager who overtook everything. Our feature test was the requirements to achieve our mission objectives, and we thought our overall successes were our teamwork, reflection and decision making. We had a lot of decision making in our project to decide which were the best systems to put into our CanSat. Our outreach, we had a very good website that put everything together, and went to primary schools and other various things. We were the finalists in the Space Colony competition at Imperial in London. We completed our CanSat on time by following our Gantt chart, which was very good. We met our mission requirements, and we got sponsored financially and technically. Financially by our school, the Institute of Physics and the Stringy Bark, and technically by Satellites, Engineering the Future and ExoMars. And our CanSat was below the £400 limit, but we raised £1,200. So for our first mission, our primary mission was to obtain pressure and sensor data during our descent, and our secondary mission was to successfully land on another planet and be able to detect indicators and evidence for extraterrestrial life. Our tertiary mission was to deploy seeds and enable terraforming of the planet, and also to drill and to get a soil sample. How we would achieve this? Well, we would detect methane, detect water, humidity, the magnetic field of the planet, and we'd also analyze our imagery and our soil once we landed on that planet.
For our planetary science, we started off by looking at exoplanets and what do we need to have for seeds to grow properly on other planets such as Earth. To do this, we found out the best soil and seeds, and then we used the specific sensors we needed to put them in the can. For example, methane sensor, humidity sensor, which was done by Alex. I was in charge of the seed experiment to see which soil was best for seeds and which seeds to plant in the ground.
For our social media outreach, we created a website and also an Android mobile app. On these things, we brought together all our media sites, so our gallery of all the pictures of things we've been doing over the last several months, and also in YouTube form for our videos. We created a written blog which states what we've been doing, which is updates everybody. It also brings together all our Facebook and Twitter feeds all in one place, and it also shows us all our sponsors.
For our educational outreach, we did lots of different things. As Alex already mentioned, we went to Imperial College London and competed in the Space Colony competition. We became finalists, and a few of us going off to the nationals after this competition. It's good. It helped us with time management and working under pressure, and it was quite a fun day. We also applied to a lot of primary schools to come and do a workshop. Unfortunately, not many of them replied, including my own primary school. But we did get one primary school, Denham Green, which we worked with really well. We did an egg land simulation. First off, we taught them about what we were doing in certain space situations. And then we gave them a budget of £1,000 to buy the parts, which were sponges, balloons and parachutes, and make the most successful egg lander to hit the ground. They all had a great day, I think. They told us that. And we had a fun winner. We've also been to Satellites to test how real satellites are made and tested. We tested our CanSat there under their special heating ovens and such. And we also had a conversation with the ExoMars engineers to give them our presentation, and they gave us some pointers.
So for our sensors, we had various sensors, and they've got points to our can. Our primary sensors were pressure and temperature. Of course, for these sensors we made sure that we had 2 of them for each, especially for redundancy. For our methane, we wanted 2 sensors, but unfortunately, because of space and the mass limitations, we couldn't afford to have it in there. So instead, we did a lot of testing, calibration, to make sure that even though we had one, it would work flawlessly. Here's our can. It's an exploded view and also an outside view. We had various issues, which were volume, mass, and power. For volume, we had very limited space inside the can to fit all these sensors that we wanted to in there. For our mass, we had to make sure that we had the 370 grams limit, and for our power, we had very limited power, and we had to make sure that all our sensors integrated together, didn't exceed, so they could all work properly.
The development of our parachute started off with simple 2D shapes with strings attached to each corner. After extensive testing in our wind tunnel, this proved to be very unstable and unreliable. So we moved on to a more complex ram air design. It works like an aerofoil wing. Air is pushed into the intake when it's descent. It inflates the cell and creates lift while it's descending, and that creates a more stable flight. The landing system, we first started off with an airbag system to cushion the landing. However, this took up too much room inside the can and proved to be too complex for us. After seeking advice from our mentors, Surrey Satellites, we moved on to a passive system. So we looked into using sponges and syringes. The final design we went with was the sponges because the syringes took up too much room inside the can. And also we created aluminium landing legs, and this would make sure that the can would land in a space when it hits the ground.
To achieve our tertiary mission of collecting sampled soil, we decided that it would be a good idea to build a robotic arm. I constructed several designs of this robotic arm, but after speaking with SSTL and microcontrollers, we decided this task was too complex to achieve within the amount of time we had. We then decided it would be a better idea to use a drill, which uses Archimedes' principle. I designed this in SolidWorks, and then we 3D printed this. But after a while, we decided this was took up too much space in the can, and the idea was completely removed from the can.
For our radio antenna, I looked at which antennas could be used effectively to communicate with real satellites, and I found the Harvey antenna. It was easy to make and it was very good at communicating, and it went the distance we needed it. I started off by making it with wood and brass rods, and when we went to test it, there was a bit of a problem. It wasn't working. So we bought another antenna. When that one didn't work, we realised we wasted a lot of money, and we tested it on the circuit board. So the connector to the circuit board was broken. Once we realised this, we changed it, and then my antenna started working. We found out that our link budget could not accompany for our sending live feed to our data, to our circuit board. So instead, we took advice from Surrey Satellites and put a memory card in with a footage in there to pick up after it dropped.
So, did we find life on another planet? Well, if we look at the data that we obtained, the temperature was within acceptable living conditions at 17.10 degrees. This is from our digital sensor, which was our most accurate. The other ones, 21.9 degrees and 23 degrees, we believe they were inside the can. We believe this was internal temperature because our methane sensor has to heat up to detect methane. Our pressure was similar to Earth, readings at 1024, 1015. Humidity, we detected water at 44.7% and 35%. Our magnetic field was the same as Earth, we received 1. Our methane value, the Earth value was 0.0017, and the one that we got was 0.00816, so it was very close to the value of Earth. We got GPS location, but unfortunately, we didn't use our drill, and if we had used our drill, it probably wouldn't have gone into us all because of the long vegetation, and our imagery also failed. So was the mission a success? Well, yes, the mission was a success. What went well? Well, we thought that we achieved our primary mission, which was to get temperature and pressure readings. We achieved our secondary mission, which was to see if extraterrestrial life could exist and to terraform. What didn't go well? Well, our drill and imagery didn't work, but we did deploy our press seeds. Our lessons that we learned. The drill couldn't be made of metal. This would have possibly allowed it to drill through the vegetation. If we had more time, we could have developed the landing section much better. And ideally, having a bigger team to spread the workload out even more would have made the project easier. And this is all in memory of Len Leroy. We've been here as Nautical Engineers, and thank you for listening.
Any questions?
So I noticed you said £1,200, and so you applied to sort of various sources. I mean, how do you sort of coordinate that? Maybe within the team or talking to teachers?
I'm not quite good at writing flowery letters for English GCSE. So I wrote a fancy letter and we sent it off to various institutes, the Horror Local MP and all this stuff, the Physics Institute. And they all replied. Some of us didn't give us anything, and some of us luckily gave us some money, which was quite nice of them. But yeah, I wrote the letter. I got the English teacher at our school to proofread it and checked it with our head teacher to make sure I wasn't making the school look bad. We could have sent off.
You designed a fellowship for stable 5. At the end, was it stable?
It was stable, yes. We have a video of it in its descent, and although we had a small malfunction when it deployed, halfway into its flight, it deployed fully, and the can had very, very small amounts of sway, giving it a bigger chance of it landing on its face, assisting the landing legs, so the drill could penetrate.
So, in terms of your secondary and tertiary mission, your secondary mission was to detect whether there was life on an exoplanet, and your tertiary mission was to introduce Earth life, so to begin the process of terraforming. Well, you're not worried about contaminating the environment. If you were to discover life on an exoplanet, you don't want to study it before you start to try to introduce Earth life.
Well, we thought about this, and we thought that we want the planet to be as similar to Earth as possible, to make the transition over as easy. So destroying other life to make it as best as it is for us would have been better. The sacrifice we had to make.
We haven't learned from the past at all.
Making the transition for us to go to this planet as easy as possible was our overall goal for terraforming.
Yes, quick question. In terms of your descent, I remember also from the video sort of refreshing my memory where the parachute didn't quite sort of unfold, and then later on it did, which actually was quite nice. Do you have any plots of the position of that descent, and what sort of speed was on average having those two stages? I'm just interested.
We've done loads of extensive testing with our quadcopter to work out descent speeds, so we could see the surface area we're going to need the parachute to be to get the 10 meters per second we want the descent to drop at.
Did it sort of happen there on average, or?
At the final half stage of the flight, it got the correct speed and correct deployment.
Yeah. Was it supposed to spin over?
Yes.
Yeah, sure.
It didn't break.
Do you know why your camera broke?
Matthew?
With the camera, the internal camera, we believe that something between the wires got a bit tangled up, so it didn't come through. We have got images, so we just need to save it out. It's a bit purple at the moment, so we need to try and try and correct the colours. But yeah.
Did your landing straps work in the end? Deploy
Well, in theory it all worked and testing proved successful. However, the problem we had was the actual dropping capsule. Once we put the actual can inside it, the tension created by the landing legs on the side would be too much for it to release smoothly, so it gets stuck inside. So we had to sacrifice the legs and just stick them into the actual can itself, looking at the grooves that were designed.
Yeah, so we could reach our secondary mission. I mean, if we can't come out the can, we can't do anything.
In the future, we would use a servo to hold the legs in, so we could have a safe release, and then during its descent, they would open out.
Yeah, we spent a bit too much time in the airbags before we realised they were a bit not useful.
Okay.
Can we run away now?
Hi Alex, well done on your presentation. How do you think it went?
I think it went very well.
Good. Anything else to say?
Congratulations.
How did it go today?
It was good.
Yep.
We also did a lot of work to hopefully win, but we'll find out later.
How was the presentation? What time was you working up to last night?
I was up until 10 o'clock.
10? It's very
and then
late.
I did some other things.
Well done to you, Alex.
It was a good shower as well.
Very good. Matthew, what would you like to say to CanSat News?
I think the PowerPoint went really well.
Did it? Yep.
Everything went according to plan.
Yep.
It's tricky questions.
Tricky.
The other
Yeah.
team.
What was the trickiest one to answer?
From the other team, the rival team, trying to sabotage us.
Yeah, I agree. James, words of wisdom again.
If you ever go to Thailand, check under the belt.
Thank you very much. Mr. Power, what would you like to say?
It's been a good 6 months. It's been
Indeed.
very tiring.
Yep.
And we'll just see if all this hard work's paid off at 3 o'clock.
I hope so as well. And team performance, what would you like to say about the team?
Team members have worked really hard, be very impressed with themselves, and even if we don't win, we'll still try and get some money out of someone else.
Very good, very good. What team member stuck out for you to be the best?
I think equally all of you contributed.
Oh, wow, that's a great answer. Ben, on to you. Hi, Ben. Oh, no, Ben's amazing. We mean the other guy.
Ben.
You'll find out later. But, what would you like to say, Ben?
I think it's been very fun.
Very fun, yes. Do you like York?
Yeah, it's alright.
Yeah.
Didn't like the school though, did you?
Okay, bit of conflict.
Do you have my charger cable?
Alex, we'll go on to this later. We're filming.